Hi, good morning, students. I'm your lecturer, Dr. Funman, and welcome to CM361 on environmental chemistry. And today's topic is on soil sampling, one of the two in sampling, environmental sampling. And in soil sampling, we'll be focused on 3 UN SDG goals here, in particular, goal number 15, life on land, because it's about soil, right? Now, I'd like to first start with a quote by Dante Alighieri, the author of Divine Comedy. There is no greater sorrow than to recall happiness in the times of misery. Maybe right now, we are still in the pandemic, we're exceeding it, but if we always try to compare what was it like before the COVID, we will not be so happy. So do take some time to reflect and give thanks, be grateful. I know it's hard, but we will try and we be positive, even if the events around the world every day is a bit more sober. Okay? I'm with you. Now, first I want to introduce to you something about the bioavailability of metals in soil, right? And this is one thing that affects the soil quality, and we discussed it in the previous topic under soil in lithosphere. And this bioavailability of metals affect the growth of plants as well as the aquatic life surrounding the soil. So indirectly, the amount of metals in the soil also affects the quality of drinking water as much as water are extracted and purified from groundwater or surface water that goes into water catchment areas. Now, according to the Environmental Protection Agency in the US, the following metals of high interest in terms of bioavailability studies, right? The Al, As, Pe, Cd, etc. And there are other metals that's possibly present in soil, include silver, barium, cobalt, manganese, molybdenum, sodium, thallium, vanadium, and zinc. Right. So what are the significance of the heavy metals in soil, right? Now we circle back to bioavailability. Bioavailability of a compound or an element refers to the amount that can adsorb by an organism across the cell's membrane. Okay, so in soil science, right, bioavailability, right, now we need to look at from the other side of things. If you have a lot of heavy metals in soil here, there's also bioavailability, right, of the vegetables, right, of bacteria. So in soil science, the bioavailability regards an element or compound that a plant can absorb or uptake via its roots. So usually, these substances will be dissolved in water, and hence only a very small amount of substance will be readily dissolved in water for the absorption by the plants, right? But some of these factors also affect the bioavailability of heavy metals right in soil. pH level, ion exchange capacity, type of soil, porosity, and the organic substance contained in the soil. All these we'll talk about it before in soil, I just want to recap. And the pH levels indicates the acidity, basicity of the soil, right, and affects the bioavailability of the heavy metals in the soil because the acidity would result in the metals existing in ionic form. Okay, so when the metals form insoluble salts with other anions present in the soil, right, they may dissolve in water, and with a higher ion exchange capacity, this would mean that there's a higher absorption chance for the organism to uptake, and so it lowers the bioavailability of the metals in the soil. Now, we also talk about porosity. Porosity is about the amount of space within the soil, and this affects the moisture level in the soil. With more water content, a higher level of bioavailability is present in the soil. So you see, it all relates to the soil, plants, absorption of heavy metals. Okay, and we can use plants, we sacrifice it to remove the heavy metals from the soil. Okay. Now, why is it important to study the effects of heavy metals? Right. Bioavailability of metals in soil is of concern because some of these metals are essential to aquatic life, right? Plants, human consumptions. But the thing is, The accumulation of metals above a certain concentration may lead to dire consequences, like there's a drop in the crop yield, death of aquatic animals and plants, as well as diseases in humans. And it's believed that rainwater may fall to the soil and carry metals along with it as it flows to the nearest water bodies, such as ponds, reservoirs, or oceans. Okay, and who's the one who get affected? Us and the wildlife. So why is soil sampling a big idea, right? We start with a case study, okay? And the question is, you think about, we have food, we have meat, we have carbo, but where do we get our veggies from? It doesn't fall from the sky, we grow it. Where do we grow it? You can say greenhouse plant, but naturally, where did it come from? Right. We look at a case study from Peru first. Here, this is an accident documented in Cerro de Pasco, Peru, and it is a city that's located in the high Andes mountain. So what happens is, right, you can read the report here in 2018. In this city, the soil was found to have high heavy metals amounts such as lead, arsenic, and mercury. And you hear these elements here, you fear as a human being. While the source of these metals are not known, the residents suspected that the nearby mines, right, of mining activity was to blame. But there could be other factors at play, like poor sanitation. Anyhow, one of the children complained about the knee in their feet. And this child is not even 20 years old, right, still growing up in adolescent age. And this child complained about the pain on the feet and uncontrollable nosebleed. Can you imagine nosebleeding at a young age, just too frequent? And then she was subsequently diagnosed with leukemia, and her blood contained high levels of lead. What is high level? 19.8 microgram of lead per deciliter of blood. And then another child complained about the painful knees and bones, and they conduct subsequent tests in the hospital and find that his nerves appear to be paralyzed, causing difficulty in the joint movement. And again, these are very young children, okay, very young, in their teens. Okay, so it's found that his blood also contained high amount of lead, and total amount of children affected 45. 45, you know, that's a whole class, more than a class in the primary school here. So other symptoms of that reported in the children in 45 were they feel nauseous, vomiting, irritability, fatigue, loss of appetite, weight loss, typical, constipation, hearing loss, and developmental delay in learning difficulties. This is atypical for first world countries like here, but in certain cities, due to environmental issues, this is what we observe. So, the regional health authorities also found that 20% of the people surveyed have about 10 microgram per deciliter of lead in their blood, which is considered very unsafe, okay, for the adults. Okay. Next case study, somewhere closer to home, up north in China, where it was studied in the 2008-2009 period, right, partially covering the Olympic Games. Now, in the village of Shuangqiao, Hunan, and the Xianghe chemical factory was built near the village, and the factory was about 50 meters from the Liuyang River. So the factory began to produce indium. Indium, without government approval, this process generated cadmium as a byproduct. Wow, this is dangerous heavy metal, CD. Subsequently, the villagers noticed that the well water contains the taste of rust. Right? When the water tastes rusty, you find it weird, you complain. And it turns out that the saucepan, right, were used to boil the water shows signs of discoloration. So people do some experiment and they observe and they report it. And what happens was one villager died of cadmium poisoning and his corpse showed discoloration on his feet. Terrible. So what happens then was that the government also closed the factory all of a sudden and tested the 3,000 villagers living nearby for cadmium. and 500 of them had a high level of cadmium in the body. Oh no. Further 4 of them subsequently died, and the number of deaths were underreported as usual, but it was estimated that at least 26 villagers died from cadmium poisoning. Now, besides cadmium, some villagers experienced lead poisoning. So see, this is very, very drastic. Now, the scale of this ecological disaster, I call it, is daunting, and the potential cost of cleanup is huge, right? So, according to a geochemical survey conducted by the Ministry of Land and Resources between 2002 and 2008, okay, 2,000 square kilometers in the area were polluted by heavy metals. In this area that stretched to Zhuzhou on the Xiang River, okay, and it reveals that the areas that are strong in agriculture, the areas rice and vegetables, and the reeds and mussels all contain elevated levels of heavy metals, and most of it cadmium. Cadmium. Okay, you think about the consequences. The cadmium level was 49.5 times the recommended level in the soil sample taken from a vicinity. It was near a smelting plant, near the municipality of Changning. Right. Another site near the Xiang River, near the Hengnan County, they find levels 331 times the limit. Goodness. Read more about this. China facing a long battle to clean up its polluted soil. Veggies get polluted. People eat them, they get polluted. Do they get exported to Singapore? I hope not. Okay. The last case study is in Europe, right? And Poland has high GDP. They give a high export. They boom a lot in the past 20 years. Strong economy. I want to show that there's a diverse case studies here. One in South America, one in Central Powerhouse in Asia, and in Eastern Europe. So it does happen in all the continents, right? Now I want to summarize the gist of this research is in the Silesia province chosen. It is a region with active mines and metallurgy, and is considered one of the most polluted regions in Poland. Some of the researchers tested 219 family allotment gardens in Silesia province. So they obtained the topsoil and also obtained the samples of the vegetables that were editable, like the carrot, potato, beetroot, parsley, celery. And they found that on average the soil contained levels of heavy metals, cadmium, lead, and zinc exceeded the maximum permissible concentration set by the national quality standards. So for the veggies, right, overall there were a significant risk to the consumers because there were high levels of cadmium, lead, and zinc found in those veggies. It is just not good for the consumers near the community. Okay, but as I say, this is more of my summary, and I'm be over generalizing and over summarizing here because it's a long study, the research paper. I would suggest you to read the full paper. Okay, so do read that if you have time.